All right, hey guys, this is going to be a shorter video. It's just basically giving you some directions as you work today together with your groups. So you are going to need your packet that I handed out yesterday to you, and you're going to need your calculator. We're going to keep working with linear and exponential models. All right, so as a quick little warm-up, Miss Jakes will pause the video. I want you guys to talk about this one. Samantha started a table to model the number of students at Bayview since 2000. So this is really the year 2000. So in the year 2000, there were 1,800 students. And then it says after 1 year, so in 2001, 1,890 students. It says, can you write an equation that models this situation and find the next two values in the table? Okay, so go ahead and pause the video and talk to your group about this one for about 2 minutes. All right, so if you guys look at this problem, I only gave you 2 pieces of information, and I did not tell you if it was going to be linear growth or exponential growth. So this totally depends on what your group thought. Did you think, hey, let's just make it be linear and let's add 90 every time? Or did you do 1890 and divide it by 1800 to see what it was exponentially growing by, or what the growth rate was? So depending which way you did it, you may have gotten 2 different answers. And then depending on that, if you said it was linear, your equation would have been y equals 90x plus 1800. If you said it was exponential, then it was multiplying by 1.05. So I would have done, my equation would have been y equals 1800, and then it was 1.05 to the x power. So totally depended. I meant to have it like this to get you kind of talking about, well, how are we supposed to know if it's linear or exponential? All right. So next thing, you needed to do this turtle problem. You were going to compare this with your group. If you did not do this yet, first of all, I just want to tell you that when you were doing your graph,
we'll be meeting in the journal.
Okay, so again, you should have graphed this table. Okay, and then we already decided that it was exponential growth. We already did that together. Okay, if you did not do this next part, you need to make sure you type in this function in Desmos under the table, and then make sure you click on this log mode to help give you the R. Once you have that, okay, I'll just kind of zoom mine real big real quick. You guys should see all of the information that you need. You should see the R, you should see the A, the B, and you should be able to do all the rest of this. And then from there, you should be able to answer the questions. So make sure you complete that one with your group and then compare your answers. Also, you'll be able to do this once I just go through all the directions. So don't do it now. Just keep listening to my directions. All right, then the main problem that you're going to be working on today with your group is this problem. It's somewhere in your packet, so you'll need to find it. I have 2 strains of a virus, and they're being studied, and they collected this data. Okay, so I have the epsilon strain and the omega strain. Okay, so what you are going to need to do, so please listen carefully to these directions before you go to Desmos. You are going to be graphing both of these in Desmos. Now, you can do them all on the same graph if you want, or like on the same Desmos screen, or you can do 2 different screens. It's kind of up to you. So you're going to start with the epsilon strain. You're going to type in this table. Okay, then we're going to try to see, well, is it going to fit better with an exponential regression or a linear regression? Which one is going to be better? So you're going to actually type in, so this is going to be your line 1 in Desmos, and line 2, you're going to type in the exponential regression equation. In line 3, you'll type in the linear regression equation. Okay, and then you're going to see, once you graph it, which one fits it better. Okay, so here would just be an example. I have a table here real quick. I'll just zoom this. If you look at the points and then look at the curve and the line, which one kind of fits it better? So if you look at my table, I typed in a table, and I typed in both of these, and then I can kind of see which one fits my data better. Okay, once I decide which one fits it better, let's say I decide this one fits it better, then I'm going to actually write the equation here in line B. And then I'm going to write what the correlation coefficient was. Remember, that shows us how strong it is. Is it close to a 1? Then it's pretty strong. If it's not close to a 1, it's not real strong, or a -1. Okay, then you're going to do the same thing with the omega strain. You're going to put the table in, and then you're going to type in both of these regression equations in again in Desmos. Okay, you're going to type both of them in again, and then you're going to say, like, which one fits this table better? Now, a couple quick buttons I want to refresh your memory on when you are in Desmos. When you are, as soon as you type it in, there's this little, I know it's hard to see on my screen, there's that little magnifying glass. That will, if you hit that, remember, that helps you see what's in the table better. Okay, so you might have to do that. You can also hit this little gear button over here. Okay, and you can actually set the X and Y values. So if you like need to zoom way out, you can do that. Or if you need to zoom way in, you can do that too. Okay, once you get that done, you're going to answer questions C and D together with your group. All right, finally, once you get that problem done, you are going to be completing all of the rest, basically anything that's in the packet that you do not have done. So if you don't have, actually, worry about this first. Then I want you to do the 13.2 homework. Okay, so I want you to try those next. You may work on this together with your group. So again, that's in your packet. If that is all the way done, I want you to go back and try the 13.1 homework. That's earlier in your packet, or 13.2 day 1 homework. Okay, so basically you're getting as much of your packet done as you can during this class period.